Hello. This video is a screen capture of my Raspberry Pi using HQ camera. The Orion Nebula is being captured. I am going to switch the video to another one. You will see a big difference. Now it's the same object but the tone stretch is different. You are now able to see the stars at the center of the nebula, aka trapezium. This is a result of the scheme I applied this time to improve the tone stretched Live-stack images on my Raspberry Pi. This shows the differences in the tone curves in the images. The left is the brightness and contrast adjustment. The right is the S-form curve tone stretch. As you can see, S-form curve tone stretch adjustment holds the light level differences in stars in the cloud. Hi. This video shows my implementation of S-form curve tone stretch adjustment scheme for the HQ camera Live-stack images in my Raspberry Pi. Each tone curve plot is shown under the image. It's a conceptual presentation though. The idea is to increase the brightness of the faint cloud part, but to prevent the brightness clipping. Let's compare the two tone curves. The left is the brightness and contrast scheme. The right is the S-form curve tone stretch scheme. The equations are shown. The left is a quite simple arithmetic calculation, so I have been using it from the early stage of my code building. On the other hand, the right has a trigonometric function and the calculation might be very slow for the Raspberry Pi. I also implement a linear slope function in it, so that highlight compression is possible to adjust. A simple arctangent function is a symmetric form, and then adjusting highlight compression level is difficult. Now you are seeing Rawtherapee's operation in Windows PC. It's easy to apply S-form curve tone stretch scheme with a flexible tone curve. As you can see, the trapezium is easily seen on the clouds. Then it's time to apply the same scheme in a Python program. I have built this program with tkinter and matplotlib modules. The upper plot shows the tone curve. The lower plot shows the histogram of the image. The most populated light level is the dark background, so the level has to be placed at the lower side of the S-form curve. Although my implementation is not perfect, you can see the tone adjusted image similar to that from the Rawtherapee. The actual implementation is very simple. It has two steps. The first step is determining the lookup table for all light levels. In this program, I apply a 16 bits table so 65,536 levels are calculated. Using the arctangent function, the array utilizes the NumPy module. The second step applying the image is done in this one line only. The NumPy array is fed to the index field. That's all. The calculation is very fast, so there is no slow down in live stacking processes as you saw at the beginning of this video. Thanks for watching this video. See you next time.